1 light year. That's roughly 9.4 trillion kilometers. That distance alone is enough to make every piece of technology we've ever built look completely ridiculous. No spacecraft currently in existence could cover that distance within a human lifetime. Take Voyager 1. It's been traveling non-stop since 1977, almost half a century. Cruising at around 17 kilometers per second, it's faster than almost anything humans have ever launched. And yet, right now, it's only about 165 astronomical units away, just under 25 billion kilometers. In terms of light travel time, Voyager 1 is a mere 23 hours away from us. It won't be for another few years that it finally crosses the threshold of a single light day. A light day. After nearly 5 decades of non-stop flight at one of the highest speeds ever achieved. However, the hardest part of a long journey is actually the start. To overcome Earth's gravity and break out into open space, a rocket must hit escape velocity, 11 kilometers per second. That's faster than a speeding bullet. But even once you achieve that, you're far from being out there. The first few million kilometers feel like a total slog because the sun's gravity keeps pulling everything back. It took the Voyager probes decades just to get past the outer planets. And where does our solar system actually end? Not at Pluto, that's a common misconception. The sun's sphere of influence, the heliosphere, stretches out about 120 astronomical units. Beyond that lies the Oort cloud, a vast shell of icy objects stretching out for a full light year. The real problem with such a journey isn't the distance itself, it's what lies in between. Namely, almost nothing. Imagine flying for years while the view outside remains virtually unchanged. No planets on the horizon, no landmarks, no events. Just stars shifting almost imperceptibly over decades. The space between stars is so empty that an average cubic meter contains less than a single atom. Even within a solar system, it takes years to pass anything that looks like a destination. But once you're traveling between stars, we're no longer talking about years without highlights, but centuries. Entire generations could be born and die on board without the view outside changing at all. Let's consider 3 real-world speeds to see what a light year actually means. Looking at Voyager 1 again at 17 kilometers per second, it would take about 17,000 years to cover a single light year. That's roughly the span of time from the earliest cave paintings to the present day. The Parker Solar Probe is significantly faster, hitting peak speeds near 700 kilometers per second near the Sun. Even at that record-breaking pace, crossing 1 light year would still take around 430 years. Then there's Breakthrough Starshot, a concept, not yet reality. The idea involves tiny laser-propelled probes accelerated to 20% of the speed of light. At that speed, traversing a light year would take about 5 years. What stands out is that higher speeds don't automatically solve the problem. At 20% light speed, we're talking about payloads in the gram range, not a spacecraft carrying humans. As soon as you factor in mass, life support, and braking, the realistic speed drops right back down to a tiny fraction. Energy requirements are another roadblock. Accelerating a crewed capsule to even a fraction of light speed exceeds current propulsion capabilities by several orders of magnitude. Chemical rockets are fundamentally useless here, and even ion thrusters take an enormous amount of time just to build up speed. Then there's radiation. In interstellar space, there's no planetary magnetic field to shield you. Cosmic rays would bombard biological tissue for years, and we have no practical shielding to reliably prevent that. Dust presents another almost ridiculous problem. At extreme speeds, even a microscopic speck becomes a projectile with immense kinetic energy. And even if the craft survives, communication becomes a nightmare. From 1 light year out, a radio signal takes a full year to arrive. A two-way conversation is simply impossible. The stars are so distant that their positions barely shift, even after a journey of a full light year. The familiar constellations would remain recognizable for vast stretches of the voyage. Only when truly approaching a target star would it slowly brighten, eventually outshining all the rest. The sun, by contrast, would slowly fade. Not abruptly, but growing dimmer over months and years until it's just one point among many, barely distinguishable from the crowd. You wouldn't feel the speed either. Without acceleration, cruising through space feels no different from standing still. No rushing sound, no physical sensation, just a gradual shift of the stars over years. Proxima Centauri, our closest neighboring star, is about 4.2 light years away. So after covering a single light year, you wouldn't even be a quarter of the way there. And Proxima Centauri is the lucky case. Most stars we see are 10, 50, or even 100 light years out. A single light year doesn't get you anywhere near a destination. In fact, it wouldn't even take you completely out of our own system. The outer edge of the Oort cloud extends up to 1, maybe even 2 light years away. You could travel a full light year and technically still be inside the gravitational sphere of our own sun. This shifts your perspective dramatically. What sounds like a colossal distance is, on a cosmic scale, little more than a first step. The Milky Way is over 100,000 light years across. In that context, 1 light year is practically negligible. A single light year pushes our current tech to its absolute limits regarding energy, time, and human endurance. Yet, compared to the rest of the universe, that very distance is practically nothing. Voyager 1 needs 17,000 years. Starshot might take 5 years, but only for a probe the size of a postage stamp. The entire history of space exploration spans the gap between those two extremes. And even at 20% of light speed, you still haven't fully escaped the sun's reach after 1 light year. We all know the universe is vast, but the fact that even the very first, smallest step into that vastness is currently beyond our reach is truly staggering.